Hello guys, so we are going to continue the discussion with respect to derivatives. In this video, we are going to discuss about power rule. Now, as you all know, we have already derived our formula to basically calculate the derivative. So if I use f dash of x, for this we specifically used a formula saying that, hey, limit x tends to 0, and then we use f x of h minus f of x divided by h. Right? So I hope everybody remembers this specific formula. But according to the power rule, and we also saw, right, we solved a problem where my f of x was x square, and when I calculated the derivative of this, I was able to get 2x, right? Now, at any point of time, whenever we are working with this type of polynomials, right? So when I say polynomials, so that basically means my equation can be something like f of x is equal to x square plus 3. It can also be something like f of x is equal to x cube. It can also be something like x square plus 2x plus 1. So these all are specifically called as polynomial equations, right? So these are nothing but these are basically called as polynomial equations. And with the help of this, we can probably create a curve. We can also go ahead and create, let's say we want to probably have a curve like this, we can actually go ahead and create. If we want a semi curve, we can also go ahead and create. And again, based on different polynomials, we will be able to get different kind of graphs in the coordinate system. Now, according to power rule, and this power rule specifically applies in polynomial expressions, right? So this basically says that if I have a function f of x, which is in the state of x to the power of n, and here your n will specifically not equal to 0, right? Say if n is equal to 0, let's say I will go ahead and write if n is equal to 0, over here, what will become my f of x? It will nothing but it will become x to the power of 0, which is nothing but 1, right? So if I have a function which is like f of x is equal to 1, right? If I try to find out the derivative of this, what will be the derivative of f dash of x? It is just going to be 0, right? And why it will be going to be 0? I will talk about it. But in short, you can also see that whenever I try to find out the derivative, and this 1 is nothing but it is a constant value, right? You can see that it is a constant value, right? And with respect to this particular constant value, whenever I try to find out the derivative, it is going to be 0. Let's see this graphically also. So here you will be able to see, let's say this is my x-axis and this is my f of x. Now with respect to x is equal to 1, 2, let's say these are my 1, 2. Here, when I probably go ahead and create with this equation, f of x is equal to x to the power of 0, right? So with respect to any x value, right, it is just going to give me 1 itself. So this will be 1 point, and this is what I'm actually going to get, right? And you know that if I try to calculate the slope of this specific line, it is always going to be 0, right? Because it is completely straight line. And when it is a straight line, there is only a horizontal movement. There is no vertical movement, right? So if I probably consider this point, if I consider this point, here you can see with this unit movement, is there a unit movement in y-axis? Is there any movement in the y-axis that is in the vertical direction? The answer is no. So the slope is basically going to become 0. So this proves that whenever I have a constant value, f of x, which I can denote it as c, the derivative is always going to become 0. And please remember this particular point, okay? So I can go ahead and state it over here. Derivative, just a second, I will write it in some other color. So here I will go ahead and write derivative of a constant is equal to 0. Please remember this particular point. And I have also shown why it is going to be 0. Because with respect to any x and y axis you take, right, my f of x is going to be just same value. Why? Because you can see over here, right, when I'm putting n is equal to 0, this is basically becoming 1, right? It is just having one constant value, and 1 is nothing but it is a constant value, right? Now, this power rule that I'm actually going to specify, this usually gets applied to polynomial regression, polynomial expression, okay? So here, if I go ahead and write, hey, according to the power rule, if I say f of x is equal to x to the power of n, where n is not equal to 0, Okay, it can be a negative number, it can be a positive number, but it should never be 0. If it is a 0, it basically becomes a constant value. So we can go ahead and find out the f dash of x by using this formula n multiplied by x to the power of n minus 1. So this is what power rule basically specifies. And this power rule is for polynomial expression. Polynomial expressions. And this is right now a polynomial expression, right? If you see it like this, right, and I can also specify, right, I can also specify this f dash of x as d by dx with respect to f of x is equal to n x n minus 1. Instead of just writing like this, I will also go ahead and write derivative of x with respect to x square, or I can also write x to the power of n is nothing but n multiplied by x minus 1. So this is how we basically specify a derivative of any value. So over here we have basically taken a polynomial expression. Now let's see some of the examples, okay? And instead of just writing f dash of x, I'm just going to go ahead and write in this way, because this is the most suitable way. In most of the research paper, you will be finding this way of writing it, right? What does this basically mean? Whatever function I have, I'm trying to derive it. I'm trying to find out the slope with respect to the point with respect to this particular axis, right? So this is my x-axis, this is my f of x. So I will just try to find out the slope with respect to this particular axis itself, right? So that is how we are basically writing it over here. Now, let me just go ahead and take some examples. Let's say that my derivative of x with respect to x cube is there. Then how do I find out my derivative? The answer is very simple, n multiplied by n minus 1. First of all, we'll go ahead and see whether n is not equal to 0. The answer is true. It is not equal to 0. It is having 3. So we can go ahead and find out 3 multiplied by x to the power of n minus 1, which is nothing but 3 minus 1. So the answer will be 3x square. Now, if somebody asks you, what is the derivative of x cube at x is equal to 2? Now I can go ahead and just equate my x value with 2. I say, hey, 2 square, or I'm just trying to find out the derivative of this particular function at x is equal to 2. The slope of at this particular function at x is equal to 2. So I'm just going to go ahead and write 3 multiplied by 4, which is nothing but 12, right? So this can be one specific example. I will go ahead and write one more scenario. Let's go ahead and write like this. Derivative of x with respect to, let's say here, my f of x is nothing but 3x square plus 1. Now see this, observe this, right? When we have this kind of scenario, what we basically do, first of all, we will take this, okay? We will take this particular value, okay? And still, I have not shown you related to constant. So let me just remove this right now. And let me just write like this, okay? So let's say I'm just going to go ahead and write what is derivative of 3x square with respect to x. Now, you know that here we are not adding a constant. This constant is a scalar value on this f of x, right? So we cannot consider this as a constant separately, okay? This is just considered as a scalar value that is getting multiplied inside this particular function, okay? So in order to calculate the derivative, I can just go ahead and write 3 multiplied by derivative of x, and here I will just go ahead and write x square. Now here we can go ahead and write 3 multiplied by this 2 will come down. So 2x 2 minus 1, right? So finally you'll be able to see it is nothing but 6x. This will basically be my answer, right? And if I go ahead and ask, hey, what will be the value at x is equal to 5? Then I can just go ahead and write 6 multiplied by 5. Or what is the slope at x is equal to 5? Then I'm going to get the value as 30. Okay. So this is how you basically go ahead and calculate. And this is what power rule basically specifies, right? Let me show you one more example so that you get more clear and crisp idea about it. Let's say if I want to find out the derivative of x with respect to 1 by x. Now in this scenario, you'll be able to see 1 by x. I can go ahead and write something like this, x to the power of minus 1. And now if I go ahead and calculate it, this again becomes a polynomial expression. Now, if whenever we have this kind of expression, it's just like x to the power of n, right? So in order to calculate it, this minus 1 will come over here. This will go over here, and this will be minus 1, right? So here you will be able to see that I will be getting minus x to the power of minus 2, right? So this is what we are specifically getting, right? And if I'm probably doing the squaring, right, what does this basically mean? This is nothing but, here I can go ahead and write minus 1 divided by x square, right? Because x to the power of minus 2 is nothing but 1 by x square. And this is what is my final answer, right? I hope everybody is able to understand this entire thing, and I hope you're able to see this particular example. So with the negative values also, we can go ahead and find out the derivative. Now, as we go ahead, we'll still see some of the examples with respect to this. But I really want to give you some of the assignments. Let's consider that you have a function f of x. So this will be an assignment. This will be an assignment. Let's say your f of x is x to the power of 8. Just go ahead and calculate f dash of x, what it will be. Okay. And I've already shown you how you can actually do it. Let's say that if your f of x is x to the power of minus 1, then what will be your f dash of x at x is equal to minus 1. Just go ahead and calculate it and write down in the discussion forum, and probably you can go ahead and discuss about this as you go ahead, right? So I hope you were able to understand this particular video. This was it. Now, as we go ahead, I will be showing more different examples, and that will actually solidify your concepts with respect to derivatives. So yes, this was it from my side. In this video, we have discussed about power law, which is something really important, and this is for polynomial expressions. So yeah, this was it. I'll see you on the next video. Thank you.